This schema presents the Dicoma systems that have been developed during the project. The objective of this demo is to have an overall vision of each system and its main functionalities. Netcath has developed a simulation and training tool. In this tool, settings can be configured. Sensor's status can be modified. When measure fire property is checked, the sensor produces fire event values. Real fire area is published in the DDS bus every 10 seconds. Forecasted area is also published every 10 seconds for predictions from 15 minutes up to 2 hours. If points of interest or crews are affected by forecasted areas, they will be also published every 10 seconds. Changes of real and forecasted areas are shown. Crew shortest path service is also provided and is based on the Web Processing Service standard. Crew movement is simulated, publishing data every 4 seconds. The crew in field conditions system developed by the University of Seville is intended to create a wireless monitoring network, which is composed by a coordinator NOT connected to a PC via USB interface. Here, you can see a crew node which must be carried by any unit of a determined crew. Node must be powered on and powered off with this switch. This is another crew node. Every time the LED toggles, a new message is sent to coordinator. At the computer, all the received messages are published into the DDS platform. Computer vision techniques have been successfully applied in the Dicoma project, where the input of a surveillance camera are processed for detecting smoke, stampedes and off-road trajectories. Once the computer vision algorithms detect disaster alerts, they determine the position where the disaster is happening and send the information to the video management and camera surveillance publisher modules. The camera surveillance messages receive all new messages of that type produced by camera surveillance producers, together with a frame that illustrates the situation detected. The output of the computer vision system is a DDS message encoding the detected disaster situation. The message is sent to all subscribers that are listening for this message in the DDS network. Event Detector is a tool developed by Mantis. It monitors Twitter messages related to forest fire and displays them on the map. The location to be monitored for Twitter messages is determined by incident messages coming from DDS. It is possible to zoom into the map and see particular message contents by clicking the markers. When the monitoring is complete, we can stop the tool by clicking the stop button. We can click on the Social Virtual Eye button to see the detailed analysis of Twitter and other social media data. Social Virtual Eye is a tool used for detailed analysis of social media data related to specific keywords. We can see a chart showing number of messages against time of the messages. We can also see the message contents by clicking the left side menu. Twitter user, message text and a sentimental analysis about the message is displayed. In order to control all the events and actions that happen in a crisis and to manage the situation, Indra has developed a control support system. In this system, warnings can be created manually or automatically when alarms that have been detected by fire sensors, camera surveillance systems or by social network control systems are published in the real-time platform. When a warning has been detected, a not confirmed incident is created in the system. The status of the incident can be modified to confirmed or finalized. The crews that have been recommended by the decision support system or the ones that are available are displayed on a list. The command control user can assign a particular incident task to a crew. The crew and task status will be updated from the data published in the DDS bus. Apart from the back-office control support system, Indra has also developed a crew field service module. In this module, the crew can monitor in real time the different tasks that have been assigned and the different status of each task. When the crew accepts a task, he will be able to change the task status, which will be published to the DDS platform. Warning messages published by a CEP engine will be received in real time in case the forecasted fire area is reaching his location. The user can update the percentage of the task progress as well as submit task reports with the progress of the task. In addition, the crew will be able to see this movement on a map as well as the movements of the rest of the crews and their status. Moreover, the real and forecasted fire areas are displayed in real time. The back-office control support system is integrated with the GIS system. The Geographical Information System will be fed with data coming from the database, the real-time platform, corridor analysis web services and also public web map services. The GIS system will show the location of each fire sensor, surveillance cameras and points of interest. If an error or fire event is detected, the sensor or camera will change color in real time. The data collected by each fire sensor can be visualized in real time as well as the real and forecasted fire areas. If crews or points of interest are affected by the forecasted areas, they will be highlighted with the minutes when the fire will reach them. The GIS system will be able to display the shortest path provided by the corridor analysis and the real-time crew movements. Depending on the status of each crew, the crew symbol color will be updated. The Decision Support System developed by ANSI is a tool that allows users to handle the crisis, manage information, analyze the situation of the incident context and provide the user a decision support system help. At the time an event is registered in Dicoma, the DSS starts working and all the generated information is sent to the UI. The crisis scene view shows the most important information of the incident. Weather information, last predictions, incident location, incident events and resources, which are recommended by the decision support system. The capacity operations offers the information of the resources assigned to the incident and their location. Resources information is also detailed on the Gantt chart. The decision support system, based on past cases, has been developed by the University of Girona. Load current forest fire scenario workflow and the available database containing past cases. The workflow contains several subtasks, each one containing its associated attribute list. Current crisis is added as a new case and the online monitoring mode begins. The application connects to the DDS to gather current crisis data, processes it, and publishes alerts about new support availability. As the crisis goes forward, the system provides online support for decision-making in the form of similar retrieved past cases. Dicoma post-mortem analysis has been developed by Justo as a web service for making easier the interoperability. Several variables can be selected in order to apply the provided analyses. Attribute selection shows the correlation between variables. Generate rules generate new rules to update the Dicoma control support system and decision support system. Teresias discovers patterns related to previous crisis. New Solutions uses the model predictive control theory to generate new combinations to solve the selected problem. The genetic algorithm uses machine learning and cosine similarity for fitness function calculation. UPC has developed a security scenario for sensor networks. One of the key aspects in sensor networks to save energy is sending as less messages as possible and still provide the service as intended. In Dicoma, we devised a protocol that organizes sensors in a tree and minimizes the number of messages the network exchanges to agree on new security keys after a member joins or leaves the network.